quickly answer this question. JAMB 1995. It says the system shown above is. So we quickly do that. Now this is a system. This block of mass 20 kg is on an inclined plane, inclined at an angle of 30 degrees, and there is a pulley here which connects it to another block of mass that is suspended vertically. So this of 20 kg is trying to pull it towards the downside of the left, towards this side. That's the frictional force. The friction between this mass and the inclined plane is trying to oppose that motion. And then you see this arrow labeled A here. It means that the uniform acceleration of this system is going towards this direction. That means they are assuming, or they are telling us, that this 30 kg is powerful enough that it's trying to draw this 20 kg upward, that the system is moving like this. So that is what this acceleration is trying to tell us, but we'll soon find out enough everything. So now, for us to determine this acceleration A here, now the frictional force that is trying to hold this 20 kg block of mass from sliding upward is given by F equals to mg sine theta, which is this sine 30. There is a video on that, on why it is mg sine theta. And then the force that is trying to drag this thing upward, or this 20 kg upward, is the weight of this second mass here, 30 kg. And the weight W is given by what? Mass times acceleration due to gravity. And then if we were to talk about normal reaction, that's the force that balances the weight of this 20 kg mass on the plane. And this force usually acts perpendicular to the plane. We label it R, we call it normal reaction. And for an inclined plane, normal reaction is given by the formula mg cos theta. It's given by mg cos theta. Okay, so let's proceed. So since this system is assumed to move towards the second mass of 30 kg, what it now means is that the tension T here is greater than the frictional force trying to hold this 20 kg mass. So in that case, that would be T, since T is greater than the frictional force, that would be T minus the frictional force, which is what? mg sine theta equals to what? The resultant force, which is ma. So if we substitute, T is unknown, minus m here is the mass of this, which is 20. Our acceleration due to gravity is 10, assumed to be 10, times 10. Then sine of the inclined angle, which is sine 30, equals to the mass, which is 20, times the acceleration we have to find. So sine 30 is 1 over 2, so that here will be T minus 200 times 1 over 2. So this will cancel. You have here 100. You have here 100 equals to 28. So we form the first equation. Our first equation is T minus 100 equals to what? 20A. So if you bring 20A to the left hand side, that will be T minus 20A will be equals to what? 100. So this is our first equation. Now there are two unknown here. We can't find it using one equation. We need another equation that will combine, will solve simultaneously to get the two unknown. So now we have finished considering that of 20 kg mass. So let's consider that of 30 kg. So since 30 kg from here, since this 30 kg is a greater, has a greater force, which means the weight of this 30 kg is greater than the tension on this string, being that the tension created on this string is due to this other 20 going in the opposite direction. But since this other one is greater than it, that means the resultant force is given by the weight of this one, which is mg, minus the tension in the string. The weight of that one minus the tension in the string will give us the final, which is mass times acceleration. And the weight will be 30 times 10. 30 times 10 minus t. The mass there is 30. 30A. Okay, so this will now be 300 minus t equals to 30A. So I'll rearrange this thing so that t will be the first term, 30A will come to the left, and 300 will move to the other side. So if I do that, I'll be having minus t minus 30A will be equals to what? Minus 300. So if you multiply through by minus 1, you have that t plus 30A will be equals to what? 300. T plus 30A will be equals to 300, and this becomes our equation 2. This becomes our equation 2. So we are going to solve those two equations simultaneously. So the first equation is t minus 20A equals to what? 100. And the second equation is t plus 30A will be equals to what? 300. So we're going to solve it using elimination method. Now if you add equation 1 to equation 2, nothing will be eliminated. Because but if you want something to be eliminated, you subtract equation 1 from equation 2, or equation 2 from equation 1. Since t here is the coefficient of t here is plus 1, and here is plus 1, so if you subtract them, t will disappear. So if I do, which one is greater? Okay, I'll do equation 2 minus equation 1. So t here minus t on top there will be 0, and then 30 minus 20 will give us positive 50A. This is plus 30 here, minus this minus 20 will give us plus 50A equals to, then 300 here minus 100 here will give us 200. Okay, so if you divide both sides by 50 to make A the subject, you have that your A equals to 50 will divide this 4 times. That will give you 4 meter per second square. So the acceleration A of the system is 4 meter per second square, which is option B. However, if you want to still find tension, assuming you are told to also find the tension in the string, so the tension T, that means you find any of this equation and substitute the value of your A to get T. I'll substitute in equation 1. So I have that T minus 20A, and our A is 4. That will be 20 times 4 equals to 100. So 20 times 4 is 80. So we have T equals to 100 plus 80, because 20 times 4 will give you 80. That minus 80, we take it to the other side, become plus 80. So that your tension will be 180 Newton. So it's as simple as that. Even if you assume that that this other 20 kg mass will be the one to drag the system to its side, that the friction is greater or what, when you calculate, your acceleration will end up becoming negative, which shows that it's not the right direction. Okay, so subscribe to my channel as a form of encouragement. Then for online classes in real time, you join my WhatsApp group and schedule a time and session. All right, thank you.